and this thing. All right? And I'll be in touch with you and this one be as well. As soon as you have this, we'll be sending you information on how to apply. It costs $650 for the two programs is the same. We'll talk about the details later on. Just go ahead.
Thank you, Camilo. And the same applies for Barcelona. For Barcelona, in Spain, Europe. There are actually more than 35 million people living in Europe compared to Tokyo, I just want to say. No? And everything is very close to Barcelona. And Jaime is over there, and I will run the 11 days.
They're taking 20 students. We're only taking 16.
And they'll be
We have 12 that have already signed because Thomas is a rock star. So I have tracked all the students. On us, give your money, sign up class. I have them here. They're there. We'll take, it's not officially open yet. It'll be in the next few days. We'll take the first 16 that they are approved. So very limited guys. And again, I would recommend if you have not gone to Japan, go to Tokyo first.
Yeah.
Last year we took 52 students to Tokyo, and those are welcome to come to Barcelona. Oh, it's an incredible city. And they always tell us.
If you have any questions, send an email. We're happy to answer within 24 hours. Thank you.
So this summer,
It's okay.
48 students will travel in different programs, right? Compared to 52 last year.
Okay.
So we're here to see the work and listen to the research and ideas of two faculty members, Claudio Rossi and Daniela Atencio, who came here as visiting faculty for 1 year. And they were teaching at UniAndes, which is Universidad de los Andes in Bogota, Colombia. And we invited them to come. They're doing Design 8, Design 3 this semester, and they did a Design 9 studio last year, Design 4. And they've been working on robotics that you will see in the lecture today. So I just want to give them a brief description of their bios. Daniela is graduated from architecture school in Venezuela. She did a master's in SciArc in LA. She's been an associate professor and researcher at Universidad de los Andes, where she coordinates computational design courses. The work that she does, the research that she does with Claudio is on advanced technologies in architecture, design, representation, computational design, robotics in architecture, computer control, published and or exhibited in multiple venues. Daniela and Claudio have been also very prolific in conferences around the world. They had also presented academic papers in the most relevant venues, and we're very lucky to have them here this year with us. Claudio is also graduated from architecture. He has a master's in urban design and a PhD in architecture. He has more than 20 years of experience in architectural and urban projects, practice and research and teaching. He has been awarded in different competitions, biennales, and invited to be lecturer or professor in many schools in Europe and the United States and Latin America. He's been invited to Penn, MIT, Politecnico di Torino, Politecnico di Milano, Melbourne University, among others. Most of the research that he's been doing is related to cities and urban issues, and he is an associate professor and researcher also at Universidad de los Andes in Bogota. Please join me in welcoming Claudio and Daniela today here.
And with that, this.
If you can start now with this.
Or you can.
Hello. Okay. Okay, thank you, FIU, for the invitation for this lecture. The Dean, Dean's Associates, Professor Henry, to all the colleagues, of course, the students, thank you all for being here. It's a pleasure for us to show and to demonstrate the research through design and pedagogical work we've been doing, named violin machines. So to start the presentation, we want to use the flip image of Caracas, Venezuela, to explore some of the consideration of violence in Latin America. But also as a journey of strategies, research questions, and design processes that let us move into a violent framework of opportunities. We must change the way we observe the region, like the drawing of Joaquin Torres Garcia, La América Invertida, or the Inverted America. The artist coined the expression with this drawing, our north is the south. From that observation, we want to expand the flip condition of Latin America by shifting the gaze of Latin America in warm-eye view, a position from below that puts the geographical systems and the society at the base. This position recalls the stereographic time configuration of Fernand Braudel, divided by three different superimposed temporalities. The structure or the long-term processes of any society relies at the base where everything is accumulated, geography, for example. In the case of Latin American region and the global south, except of those where indigenous cultures still live, there is a readjustment of that diagram. Big cities occupy most of the geographical surfaces, making every action violent. Violent. Okay. So big cities occupy most of the geographical surfaces, making everyday actions a violent intrusions. So if we want to expand the responsibilities of any architectural project, we can use time as a diachronic, transversal tool to connect the present and to a possible better future. In other words, to make every project an ecosystemic, social, evolutive link. That is what we have called violent machines. These machines are meant to be acting along the region. To establish those possible locations, we redraw our initial Latin American warm-eye view to expand the representation of using these Braudel's temporal structures. Also, to change the stereotypes made in the representation of our region, where progress, militarism, corruption, poverty are mixed with a beautiful landscape and exuberant ecosystems. However, part of these representations are true. In real life, division, segregation, and a convulsed, violent urban and rural condition overlaps, as we said, with a great geographical structure. A reality that is common in our region, like Petare in Caracas, in this case, one of the biggest favelas in South America. So we understand violence either as an everyday human action upon a landscape system, like processes of urbanization, inequity, pollution, illegality, etc., but also as an accumulated effect of planetary processes, global warming, sea level rise, greenhouse effects, among others, but overlap to a beautiful and convulsed reality. Latin America is the main platform for that exploration of these actions and possible optimistic solutions, grasping its own reality and from the base of multiple agents, human and non-humans, backgrounds and logics. Everything, if we want everything that we want to present today is part of that continuous process of testing, adjusting, and operating in that reality. That is a violent machine. However, outside those urban conditions, there are some other fragile landscapes, like the desertic frontier between Colombia and Venezuela, La Guajira, which actually is the place very close to where we come from, where notions of divisions or limits do not exist. It is a landscape of expansions, permeability, transitions, but also a place for another kind of violences. This region is a place of beautiful ancient indigenous cultures like the Guayú or the Añú, where, for example, the women have many roles, like finding and carry water through the desert. Together with the donkey, her daughter, the water seeker walks and sings through the landscape. The human action find a scenario of planetary reactions, as presented in the research of Richard Weller and others about name it the Atlas for the End of the World. Threatened through planetary effects, like as an example here, the sea level rise, presented as a future drought in black. However, there are many other interesting paradoxes in that atlas. In one hand, the observation of plenty possible places of opportunities for saving the world or possible biological hotspots, and their location, many of them in the global south. Overlap to that, to those optimistic places, the biggest concentration of military guerrilla conflicts and political corruptions. So we must find new ways of designing those strategies. A way of seeing that condition is by taking the critical images of Mark Tansey, his paintings, as a metaphor for human impacts in the Anthropocene. We use the Achilles entortoise by Tansey to make a provocative image superposing these considerations, but also to propose an emerging new artifact where the position of nature and technology blends. From those considerations, we want to propose our violent machines. We will present today that into two chapters by elaborating some of the design and pedagogical processes as interconnected realms. So the first chapter will be the violent artifacts. From the interest of exploring this condition presented by Tansey, Latour, Weller, and others, we propose a shift in the definition of the architectural typologies by replacing it with artifacts as a transitional tension between objects and machines. But what is an architectural artifact? Well, for us, the answer correlates in some of the properties expressed by Milton Nam. An artifact is, from its morphology and specific significant form, specific in terms of the materiality and significant by its beauty. But Nam also recalls that an artifact is an invention. It must be produced through a process of work, design, experimentation. So we design and teach these artifacts from specific challenges. Programmatic imagination, the bridge between materiality, responsibilities, time, and the process of representation mediated by technology. It's a journey through strategies and tools in Latin America and many other places. Garcia Marquez, Uslar Pietri, Benedetti, Borges, Watanabe, and many other great Latin American writers have developed their novels based on the real observation of Latin America. Garcia Marquez, for example, once says, in Latin America, there is no greater fiction than reality itself. So the magical realism, using the narrative technique of Garcia Marquez, defines the society, our society, that is full of contradictory surprises. Programs that seems to be in contradiction can be mixed playfully with many other possibilities. For example, a vertical zoo and an elementary school that cleans the air. Enrique Siriani also recalls that the architecture should be explained by responsibilities. In the contemporary scenario, these questions must be addressed by the materiality and the environmental role of the artifacts. So recalling Braudel and answering the question of how we can narrow the relationship between long-term geographical structures and the present, well, throughout understanding time. And the representation and the mediated by technology is a transversal connector. This image, for instance, is in the polluted coast, Pacific coast of Colombia, where all the waste that flowed north move by the Humboldt current and end up accumulated in that specific spot. So the use of drones, LiDAR, photogrammetry, and advanced modeling enrich the representation and the process of research for a possible machine.
So, as the first exercise, we wanted to present our recent work for Los Angeles Fire Task Force, developed in response to this year's wildfires in Southern California. This project has been selected for an exhibition beginning October 3rd at SIAR in Los Angeles. We have named the height land, although it's not located in Latin America. It is part of the biological scenarios of action outlined by Richard Weller in the Atlas of the End of the World. This project advocates for that broader framework of a planetary megastructure of ecosystems. South Florida, for example, is also part of those biological hotspots. The reconfiguration of Los Angeles landscape began early in the Hollywood land real estate development. Earth-moving machinery reshaped the native topography and inscribed what would become one of the city's most recognizable emblems. The word land was erased from the iconic emblem, marking a permanent rupture in the sign of the original form. In the last century, the Palisades served as a site for a night missile platform during the Cold War. Today, these installations in the upper reaches above San Fernando are decommissioned and closed, situated precisely with one of the most critical zones of the 2025 wildfires. The proposal, situated with the Palisades Mountains, materializes an environmental gesture of urgency, what Latour calls the terrestrial turn, an imperative to ground action within the Earth system and cycles. The intervention claims and it's anchored to that missile platform at San Fernando, extending the iconic Mulholland Drive through the architectural machine. The word land, once an important element at the hills 100 years ago, it's now a signal recovery after the 2025 fires. Its intermittent visibility evokes to the legacy of the land art while gives territorial identity through the ecological properties. Central to the design is a system of 4 vertical towers, simultaneously infrastructural and symbolic. Using the silhouette of the Hollywood sign, these scaffolds no longer serve as a landmark of the urban industry, but function as a water harvesting instruments. A cistern links 4 water harvesting artifacts, a tower for each one of the words of land, conceived as a machine that transformed over time. The artifacts traverse a continuous concrete base and integrate 2-mile fire break, a cistern infrastructure at the top of the mountain. Multiple operations and components converge in the materialization of the machine, including what we call the machine and performative components. Their orientation, particularly with the use of high thermal inertial panels such as the limestone, prefab cement panels, or travertine slabs, increase microclimatic variations to produce condensation and support native vegetation regeneration. This machine is composed of an scaffold that supports those stone panels. It's conceived as a new emblem on the mountain, while functioning as a protective infrastructure in the event of fires. Time is a constitutive factor of the project's material logic, driving its agency and securing its anchorage within the landscape. The construction narrative over time expands that critical dimension. It integrates aligning its cycles of construction, the use and restorative actions with the seasonal regimes and community protocols, so that the project's agency grows with the landscape rather than acting upon it. Each tower serves as a modular component within the broader ecological choreography. Their connections, mobility, and functions as environmental artifacts and social observations allow them to perform that as a dynamic and responsive agents. It will rewild the surfaces, infiltrating water to enable in the ground to regenerate vegetation across the areas spared by the fire. It also reframes the landscape, remembering the land in the high point of the mountain. Time, again, is the key feature in the exploration. The choreography of time aims to explore its architectural capacities. Moving back to Latin America, the next project is located very close to La Guajira Desert, in the new indigenous region, La Laguna de Sinamaica, or the Sinamaica Lagoon, in one of the most polluted water scenarios of the region. This project, developed for and founded by the Embassy of the Netherlands in Venezuela, in collaboration with the journalism NGO Destierro Climático, it's anchored in the systematic documentation of the lagoon as a foundation for design and inquiry and territorial intervention. By 2001, the lagoon was a remarkable water of body. Much of its lakes, corridors, and river connections were working and connecting all the new villages, as well as the active ecosystemic services, the flora and the fauna. By this year, we can see a silted, polluted, and desiccated lagoon just 25 years after the previous image. The crisis of pollution, malnutrition, and systemic social deficiency have threatened one of the region's most vital ecological landscapes as part of the ancestral indigenous community. The lagoon is sick. You can hear from the new leaders and residents who persist against the climate displacement in search of a better future. We'll always go back to the footage documentation to isolate the single frame, the time. The proposal envisions a floated machine, a moving horizon, that will clean the water at the lagoon in its path, while simultaneously becoming a pedagogical infrastructure fostering a dialogue about care. The platform acts from the understanding of local practices, the coexistence between the inhabitants and the sick body of water, by resignifying the wonderful scenario of atmospheric privileges. A reinterpretation of Robert Smithson's Floated Island in 1970s, developed by Balmori in 2005. Additionally, serves as a field laboratory for growing, displaying, and learning, an itinerant device that moves across the lagoon, convening dialogues and renewing ties between residents and the territory. A machinic ground, both passive and cultivated, that guarantees access and enables mobility and serves as a minor infrastructure to grow food. It also dignifies the new culture, especially the cattle weaving, while adapting to the site's thermal and humidity regimes, insistent on its material value. A moving horizon, a cultural and environmental machine.
So from these explorations, we want to present some academic and pedagogical results that have materialized diverse local challenges in our design studios. These machines are located using the same representation narrative platform Latin American World My View. We selected some of the projects in a diverse constellation of multiple interventions in the region, organized by a specific landscape where the machines are acting. So talking about violent places, we can't skip the damages of the quarries in places like Bogota. This proposal works as a social catalyst for the spontaneous settlements in the surrounding this place. Here, representation of the reality through technology became crucial. A comprehensive point cloud map was made to understand the microsuperficial runoff of the rainwater and use it as a system of care, collecting it into a water public cistern. A section materialized the two main components, the water collection cistern and the existing cave used by the miners of the quarry already extincted. The complexity was studied and presented in a physical models using different 2D and 3D fabrication tools. Carving some materials as a process to understand the erosion of the mountain versus fragile wooden work that recalls the regrowth of the original forest, the Bogota Piedmont. Another kind of projects are meant to be ruined or emerging from them. In this case, a project in an abandoned mine in the biggest Paramo high plateau in the world to help the recovery of water and the restoration of that ground. The project works as an interface that will be ruined over time by collecting and infiltrating the rainwater and atmospheric water into the damage of the soil, the damaged soils of the mine. These processes were explored through digital models and AI, but also by a physical model that actually, this is very cool, a physical model that was in the process of ruination in real time, in real life, because of the 3D printed materiality. In this case, some infrastructures were designed to protect the southern coast of San Juan de Puerto Rico against the sea level rise and hurricanes, and to give economic opportunity to the inhabitants of the lower part of the ancient military wall. A representation of that reality of San Juan was explored through a huge physical CNC model to then test the machines in place. In this case, the requalification of 3 abandoned water tanks in the middle of the mountains of Boyacá, Colombia, to make a social environmental infrastructure. Some specific strategies to renaturalize endemic species, but also to harvest water for the countryside, using digital models to explore the materiality and the tectonic of the walls, the ground, the forest, and the expression over time of these components. The recovery of a military abandoned base in Beques, Caribbean Sea, using the ruined bunkers to make a vertical health research public facility and a water cleaning infrastructure. The drawings shows the mixed reality of the hybrid representation of programmatic imaginations, material capacities, and responsibilities, but also using the section to explore spatial qualities over the vertical machine. The physical model in this case was sliced to explore those connections horizontally, but also the vertical thicknesses of the programmatic structure. In this case, a landscape armature in Santa Cruz Island in the middle of the Caribbean Sea, one of the most occupied islands in the world. The materialization in that circular artifact was developed by different chunks of the circle, but also from a very special model, a physical model with precise digital fabrication, serialized processes. The mix of different techniques show the material atmosphere of that proposal, but also the technical constraints, for example, in the bathymetry. The intervention of a contemporary ruin, the abandoned museum of the memory, contradiction, of Colombia, built but never finished, and these artifacts amplifies the definition of memory by infiltrating into the abandoned structure, birds to nest structures, but also rainwater to capture those in open gardens. Iterations were tested to develop the different components of the artifacts and explore and materialize through physical models that show chunks of that intervention. An abandoned railway in the middle of the Magdalena River became a spot for design a machine that dragged the sediments in the adjacent creeks to recover the riverbank ecosystem. The materialization in a vertical machine also served as a landmark, was a social infrastructure for the fishers. Explorations with the model to explain the architectural capacities of those changes in the sedimented topography. For instance, this project in Honda used technology to describe with precision the materiality and the spatial quality of the existing process of origination of that town, together with the minimal infill artifact that will give a possible future transformation to this place. A hybrid advanced digital modeling process to show the assembly of the different components, but also fabricated. The reuse of 1 mile abandoned coil dock in La Guajira to design a new artifact that mitigates with the sea level rise in the Caribbean coast. So technical issues like the behavior of the level of the sea, the bathymetry, tides, wind were modeled to understand and design the different artifacts in the horizontal infrastructure, but also the infrastructure proposed a continuation of that desertic surface. The transformation also served to the CNC model, a very long model of the dock, and also the fragile racing devices. Why racing and why fragile? Because those devices are a programmatic system of artifacts that will be moving around the coast for different docks abandoned there. Or in this case, an infrastructure resting directly on the water dam of Hidroituango in El Cauca that have damaged a lot of the ecosystem in the area. The machine is a landscape armature that reconnects both sides of the river. So the physical model was a huge model to build a large scale showing that different materials and arrangements along as a vertical mobility solutions for fishes to be connected and also services for the fishermen, working as an escalator using the energy of the water depth. The exploration in this case started with the ancient Colombian railroad hangars. Sorry, stop it there. As an opportunity to serve for endemic nature, but also providing a new public space in Medellin. The model explored the double condition of the existing industrial envelope and the carved, eroded ground, the complexity of the surfaces, and the signification of that specific place. And finally, an infrastructure for the recollection of waste in Bahia Malaga, Pacific coast of Colombia, shown before. And as mentioned before, the complexity of this project was in the area through computational methods and representation of fabrications. That information served for a large model to graph the complexity of the topography and also the reality of that artifact.
The second chapter of the violent machines is the journey with the use of the robotic arm as a design agent in architecture, both in the projectual and academic practice. We have named this chapter the pedagogical machines. This journey was amplified during the pandemic when we had the opportunity to actually go back to our campus at the University of Los Andes. An ABB robot was installed there since 2018, but it was completely unused. So we started to develop a design and design possible strategies to work with the robot. Material additions, form finding processes, and of arm development, along with safety protocols, workflows, and design tests. Many materials were tested, and we started designing tools based on the devices that we actually found in our Fab Lab, adapting them to our robot through custom 3D printing of arm tools. To mention some of those, we designed a custom attachment for a motor tool with different beads, a heat gun, a camera, among others. These were the first set of design machines. We also started looking at the possibilities of combining them and adapting the process to push forward the design processes. A challenging aspect was the particular environment in terms of the software. We don't conceive our practice as isolated process from the academic research. We actually teach and design what we actually research. So from the academic point of view, most of the universities in Latin America still do not have embedded computational thinking and design concepts in their programs. In our case, we were researching with robotics at the same time as teaching software techniques as Rhino, Grasshopper, Python, etc., which is probably not the typical way to do it. So by exploring and prototyping with those machines, we created a workflow based on a process that we defined the translations. These translations challenge the idea of using the robot as a design agent and not as a fabrication tool. In other words, not seen as a tool for a final result, but a creative open to agency and tolerances. From an infrastructural perspective, the robot is the bridge that have the capacity to connect across boundaries and overcome possible obstacles between the digital and the physical domains. We developed these translations to speculate and to structure informed design processes, including algorithmic programming, robotic fabrication, and post-computational techniques. The first of the translations is the analog. This alludes to an anatomical conception of an image and approaches to describe possible hidden capacities. The trigger for this workflow is an object of study, for example, the Cartagena military wall or a specific landscape area, to do a detailed registration and observation. This process also recalls to Bruno Latour's observation of the thickness and the thicknesses of materials. The second translation is the digital, and this extends to my exhibition at the Venice Biennale 2021, which examined how images shape the legibility of objects as an axiom of the image that generates further images and artifacts or new ones. So the digital translation starts rereading the analog artifact to accumulate explorative iterations from where robotics toolpaths will be generated. The outcome of this translation ended up in multiple prototypes and new objects, as well as multiple toolpath simulations. The robotic or physical translation involved two processes. The first, the transformation of the digital artifacts into physical objects, but the interpretation, and also the interpretation of the geometries and the toolpath effects. The second, the reconversion of the edited physical objects back into the digital artifacts using choreographic movements of the robotic arm. Therefore, the materiality is transformed from the program toolpaths, understanding the technical specificities, weight, density, mass, speed, among others. This process was automated and repeated in different iterations, as we can see, generating effects with similar results. We adjusted speed, depth, data, thicknesses, as well as allowing specific agency to the robot. This process demonstrates a diverse and strange process in the relation between ideas and design explorations, challenging the traditional notions of form, finding, and representation. As we can see in this image, the results are mixed scale of resolutions with multiple potential architectural capabilities that we will see later. The exact path of the physical translation was repeated, referring the camera tool to the digital platform. The scanning allowed the recording of geometries captured in greater detail. We call this translation the inverse translation. The precision of the robotic choreography allowed to generate multiple resolutions from the massive number of images captured with the robotic arm, and in other words, the exact reverse journey from physical to digital. So we would like to also show a set of different projects to expand the translations as design process through research and creation projects, from translations to design processes. This is the first of many pedagogical machines, the program Renation, that's how we call it, in the Mojave Desert landscape. This project aims to investigate the tension between assemblage and monolithic readings of the artifact. A process of aggregation is used to form an artificial landscape which establishes the foundations for the design of an agricultural and water preservation infrastructure in the desert. This aggregation system forms a non-uniform body with moments where landscape transforms into monolithic elements, including erosion effects. This natural phenomena of erosion is very difficult to control, and it acts randomly. So by digitalizing the process, it moves from a natural erosion to a controlled artificial rustication. The result of the artifact yields a tension between the natural and the artificial. The digital rustication is made possible by the robot arm, following the precise tool path, and it textures the surface of the physical model, giving it detail at an architectural scale, and that can be repeated with the same rustication effect many times. This approach blurs the threshold between the artificial intervention and the context through a systematic approach and entropic effect. So, the second pedagogical machine, we would like to show it with a local experiment, specifically in Lincoln Road, that we call the vertical and horizontal archaeologies. So, the progression, we did like 12 vertical objects informed from historical images of the site, fabricated for an installation along Lincoln Road. They stand as witnesses and testimonies of the site's past. They also prefigure the site's future, a geography increasingly at risk from the sea level rise. The historical landscape informs the object as an image archaeology that through computational processes grants the 12 pieces with material textures. The operations are precisely designed to embed controlled degradation through material stress, surface erosion, and calibrated thresholds, so that the objects emerge as intentionally ruined artifacts. These operations are computational protocols for its construction. There is no such a thing that isolates these two processes. As Campo Baeza will say, we design to build. Technology functions as a precise mediator. Toolpaths, tolerances, and protocols render a rigorous and legible fabrication process where precision and poetics actually collide. Each one of the drawings reveals a hidden parts edited progressively by the robot, exposing its internal materiality as a form of archaeology, both vertical and horizontal. These artifacts are conceived as a public infrastructure at the hinge between Lincoln Road and the beach, where urban and geographic logics intersect, merging the past, the future, and actually the archaeological future.
Based on those translations and the workflow, the previous research experiments, we want to present two different pedagogical results. We call it ruins and landscapes. The first one will be in Cartagena de Indias, Colombia. The starting point of this we will all go back to the workflow, the same workflow. In this case, we use the military wall. The 17th century infrastructure, an ancient military machine, although named UNESCO World Heritage, can be considered an artifact in ruination, which is a temporal and historical beauty, but at the same time a new emerging material and environmental characteristics are growing. On the main issues of today's condition of that wall is actually the missing part of the system, demolished by different political decisions to make a road, to build a store, etc. That makes the wall an incomplete system. The design challenge in this case was to complete those spaces of the wall and actually giving them new capacities. The wall is a ruined infrastructure in a process of reconstruction, we can say that. In a few hundred years, could become a reef in the shores of the Caribbean Sea thanks to the sea level rise. A military wall that ironically will be a defensive wall against future anthropic effects. The first process that was the understanding of the part of the wall, walls, doors, parapet, towers, all the elements that are part of the wall. Also, detailed observation of data gathering of the description of those processes of deterioration and physical wear. These geometries and material capabilities are transformed into the toolpath, and the robot start to work with those images, from those images. After that, the carving editing processes start making different objects that translate those capabilities in a new arrangement in different objects. It is possible playing with the materials, texture, beads, speeds, among other factors, using also different materials like the same limestone of the military wall. The physical robotic objects are produced in translation of the workflow, but also the registration and the translation of those objects back to the digital realm. A set of digital iterations that build up the artifacts, informed by the process and located in one of the incomplete part of the wall. This is one of those in the corner of the wall that connects an outer part of the Cartagena Bay and the existing doors. So new responsibilities are tested in the configuration of those violent machines for the wall. Actually learning from that analysis, some of the interpretation of the stone's qualities like porosity are part of the new arrangements. At the end, the artifacts that completed the wall were placed in a large model in the wall of the city wall of Cartagena, actually completing all the missing part as I mentioned before. But also, all the objects were exhibited to show the process. The second case is La Guajira. We will move back to the desert in the northern frontier between Venezuela and Colombia. So we apply the same workflow, testing at the landscape scale and the design processes behind that. Gathering information from the landscape informed the process. In this case, the challenge was to produce an artifact that reprogrammed the deserted territory, but also that recovered part of the challenges for the Wayuu community, access to formal economy, services for the community, children's malnutrition, among many others. In addition to those challenges connected to planetary constraints, for example, the mangroves have almost disappeared from the coast. But also dealing with one of the territorial biggest damages in this area, which was made by the extractive activities of the salt industry. preserving part of the highways, which is a kind of a special water infrastructure for the Guaymas. So the analog translation in the landscape started the same process, gathering information for the images, then the translation into the toolpath, the robot started the object making, and the design process started. So using the wonderful, behavior of the robot as a design tool, editing these objects and inform toolpath to make an expression of those. The digital translation of the object after the operations give that information, that digital information. So assemblies could be made by the hybrid information to build up a pilot machine. These reorganization are strategies in different places in the Guajira to actually have a vertical intervention that make some catalyst effect in the desert. The vertical machines will have the material capacities to get ruined over time and melt into the landscape. So after helping the regrowth the mangrove in the coast, but also protecting the recovery of the desertic area, we will have a transformation. The materialization of vertical machines using the surfaces to make a drastic changes in temperature, positive factors of condensation, process of infiltration, etc., etc., etc. And also, at the end, the exhibition of the process as part of the design. A final CNC model were fabricated to allocate the different operation of our students. In this close-up, you can see the machines placed in a specific location of that model of the system. So running previous exercises and expanding our research questions, we test different iterations and some of the specific workshop changes. Working with changing the site and changing the tools in collaboration with Southern California Institute. In this case, we are going to talk about the Mojave Desert, and we use LiDAR scanning and robotics abstractive techniques to push the challenge. So the starting point was the registration of a specific area of the California desert to understand the geological conditions, also climate, chronological conditions, wind, temperature, shadows, etc. And we use the LiDAR scanner to trigger that translation. We readjust the workflow to actually work with the giant, huge ABB 6700 and run the previous several tests. This is the monster. The robot or arm gave us the opportunity to do bigger translations. So if you see the different scale on that. And the operation with those objects to achieve a bigger informed artifact. It was very interesting, the change of scale and the level of additions we did with this guy, and the transformation of the editing processes using the same workflow but with different capacities. As an outcome, in this case, the objects edited with the robot testify the info gathering from the desert. And actually, as a result, we have different and deeper levels of resolution made on those objects. A second exercise of this, a second experiment with this, same robot was on the LA River using LiDAR in this case, AI and robotic additive operations. So in this case, the name of that exercise, we call it textures, and we use the infrastructure urban condition of the LA River in the nearby eroded space of the bridge, of the new bridge of Michael Madsen. It was pretty much based on the challenge of learning from the texture of that mineral infrastructural landscape to actually from that have the information to build up a new machine, a new environmental capacities for the river. Part of the challenge was the construction of the bolted structure artifact from the complex geometry using the same robot and challenging the 3D additive extrusion to actually make a huge bolt to confront a bowling machine made of pieces over the river. So at the end, the registration of the bolted machines and the materialized expression of them was very much the outcome of this exercise.
So the final experiment of this chapter is the Desert Sea Robotic Circumstances exhibition. The video shows the transformations in the same place in two different moments of the year in La Guajira Desert. Desert Sea was exhibited at the Pavilion International Research Creation event in 2023 at the University of Los Angeles, and it was a circumstantial materialization of La Guajira Desert from two approaches. The first, from the translations of temporal and spatial processes expressed with a robotic arm, and the second reading was the circumstantial space of the robot reminiscent of the POE for the Wayu Jonah dance, which is based on their cultural dance. Images of the desertic landscape were translated into code to process the robotic toolbox. Those landscapes were tested in the process through simulations and operations using a custom tool. The robotic choreography was programmed to execute the addition of the 12 vertical witnesses in a 3-day exhibition with different sessions open to the public, where time was based on the materiality of each one of the totems. Several iterations were made for the exhibition final design, but also presented at the event as a part of the design and research process. The pieces meant to be transformed during the exhibition by continuous action of the robot. So any adjustments were made to set up a precise and transformative changes and effects. Each witness from the application of the workflow translated the observation of La Guajira Desert into geometries. That is, the landscape was excavated from each one of the blocks from the collision of geometries captured. After the wooden pieces were fabricated with the robot, they were filled to reestablish their original shape with black paraffin. After multiple tests with different materials, some more sustainable than others, paraffin was selected for two reasons. Firstly, because of its capacity for transformation, for example, the behavior and expressiveness. But second, because it is a material that comes from the petrochemical process of oil, which is a local material. La Guajira is and has been colonized by a central extractivism practices from salt to oil. Therefore, this material had and will have a degree of material criticism. The robot edited the material through high temperature air using the thermal blowing tool made specifically for this exhibition, creating a double reading. The first, from the interpretation of the heat of the desert, its population and its culture, but also as an effect of global climate change on these territories. The second reading was from the circumstantial space of the robot as a metaphorical representation of the POE for the Wayu Jonah dance. This is the first day of the exhibition, and this is the third day and the last day of the exhibition. It was open to the public without any boundaries around the robot to experience the transformation of the objects in different moments, which is really hard to do, but also the smell and the heat produced by the editing process of the robot. The results reveal a transformative and performative landscape hidden over time. You can see some of the close-ups of the totems during the exhibition. During the 3 days of the exhibition, those hidden landscapes in the mass of the witnesses appeared, and the materiality that concealed them melted away, like a kind of robotic archaeological dance on the most structural basis of the landscape, its geography. As Ortega and Gasset proposes in the mediations of Don Quixote, space is circumstantial, as its etymology alludes to the positions that surrounds the ways of inhabiting. The stages of changes and transformations are similar to the dance of the La Llona. Changes and micro-transformations in the material were shown during the exhibition. This is the circumstance from day 1 to 3. Between material objects and vertical witnesses, and the interpreted results from transformations and material behaviors. The exhibition connected all the research through design previous processes, working with technology to represent ideas, processes, mechanisms, and behaviors. Objects that translate into objects, objects that inform objects, and machines that drive different ways and workflows for the design processes. The Rossi asks about the past and the convulsive but beautiful present and a possible future transformation of the landscape in Latin America. So all this journey and the connections between each part of this presentation is in the comprehensive content in the book recently launched and published by Actar that you can buy also. Pretty much the work based on the methodologies with the robot. And also maybe we will never find a better moment to extend an invitation for our upcoming exhibition in December the 2nd at EMBOS, which will be called the Ancestral Apparatus. And it's an exhibition, but it's also like a goodbye exhibition because we're finishing our visiting position here at FIU. And it will be pretty much based on the Hawaii apparatus in La Guajira Desert and the transformation over time. The Hawaii is also like the main trigger that we have for our current design aid studio, and our students are here in the first row. Thank you. So we would like to finish with a wonderful quote of Jorge Luis Borges, remembering our context that says, "Nothing is built on stone, all is built on sand, but we must build as if the sand were stone." Thank you so much for your time.
Thank you for the great lecture. 50 minutes. We have some space for questions, comments you want to ask. I do have a question, but I'll wait for students, people in the audience.
Okay, no questions.
Well, I do have a very practical, technical question. So the work that you show is mainly student or studio work with students. What level of students are those? Is it undergrad, graduate, student?
So the ones that we show in the beginning, more like focusing on the Latin American landscape, those are thesis undergraduate results. And the ones with the robots, pretty much like related with design aid, pretty much like 7-8 semesters of the undergraduate program.
Undergraduate students.
Yeah.
Which is a huge thing because at the beginning was the use of the robot, for like to take advantage of the technology that were already installed there, but at the same time to build up a pedagogical track to use it as a tool for design in an undergrad architectural program. So it is not like a fabrication tool; it is much more an agent in the design process.
Yeah. Usually robotics are more like focused on master degrees, actually I learned that way, and also obviously PhD. But in this case, we wanted to test like how is it going to be like for undergraduate students, and it was actually the first course using robotics in architecture in an undergrad level in South America. So that was interesting. Not easy, obviously, but interesting.
For us.
Stephanie.
I see a lot of your work about it, right? That you work in layers. So how you end up having that workflow through all your projects? That you can, I don't know how to say it, but another component. So I would like to know how you end up working that way on each of them you have to each project.
Okay, so for example, we're doing a similar experiment, let's say with our DA students, and try to explain this in the first class, like we're going to get to this. It's really difficult. So using technology, we think that we have to, as we mentioned, like maybe like divide it like in layers, and each one of those are like a critical process for the overall outcome. So we cannot jump from the first one to the last one because we'll be like missing the opportunity for the exploration and to explore materials, conditions. For example, if the input is La Guajira Desert or is it the Cartagena military wall, it would be like completely different outcomes and results because that's only that it's different. So it's also, I mean, as Claudia was saying, what you just said, it's going to be for students. So we need to find a way to actually test before what we're doing, but also a process that in a pedagogical way they can learn it. It's really difficult to learn robotics. Like actually, this course was only 8 weeks. We have there like 16 weeks and 8 weeks courses, and it was only 8 weeks. And they actually have to come up with an architectural resolution. So in some cases, just using and trying to learn the robot, you will take the 8 weeks or even more. I took 1 year in my master's degree. So, it's like a pedagogical composition and activity to actually transfer it to the students.
But also, what is beautiful about working with the workflow is actually the adapting of a system, of a pedagogical system you will use. So you have loop, you have like dead ends, and it's part of the process. And finally, to add something to that is, we teach, and what we teach actually we also provide all the tools to do that. I mean, we do teach with tutorials and specific information. How can you do this or that? Well, let me show you several techniques or several protocols so you can find a way to do your own, like adapt it in your own process of research. That is the most important thing. In every creative process, architecture or any other realm, part of the involvement of the student is crucial, because it's the one that actually will adapt and, using our words, translate those generic, let's say, tracks of a workflow into a own questions and answers to the process.
It is also one important thing is that it comes from our research. So this is a way how to do it. So it has to be done like in this specific way.
How did you guys decide that this is going to be like your focus, like with the environment? You know what I mean? Like how did you announce what you're doing?
That's a great question.
It's a very fast. For me, it's a very fast answer. I mean, I knew that I knew that I wanted to work with environmental things, let's say, like the crisis of environmental aspects, and also technology in the 15th of December of 1999, that specific day. Because I was going out of an urban design program, I wanted to do a PhD, but that day I was finally ending up my master's degree, and I was just about 5 minutes to take a plane to go home on the December holidays. And that day was the disaster of Caracas. I don't know if you from the Venezuela know. 1999 was
Landslides.
the landslide, the big landslide that destroyed like a huge amount of the area, and people died. A lot of people died, and I was there, like not there in the city, there in that place. So I saved myself, and I immediately said, you know what, we need to. This should be understood in a different way. And technology, because in that moment, all the technology to understand that we needed to use GPS. Well, GPS was a military technology. Nobody used GPS in a kind of open access. So I said, these two realms need to find a connection.
Yeah, also your life as an architect or designer could change a lot. I always do the same joke that Claudia started medicine 2 years before architecture, and if you have a headache or you can ask Claudia while you're in campus. But it changes a lot. In my case, obviously I was an architect. I was already teaching for 4 years, and I wanted to do something like completely different from what I learned at school. And that was when SIRE was one of the first schools that actually included the robots. It's like the robot house. So to me, it was like I wanted to learn something like additionally that I didn't get during my undergrad. And that's pretty much like also like the idea that we're trying to introduce like those topics in the undergrad. So you can choose, for example, you see housing when you're studying, and you can actually follow that path, but also you can follow the technology or specifically the robotic path.
Olivia Taranto.
Or you can study medicine after architecture.
Pavleen has a question here.
Sure.
Students and family. Yeah. So
very interesting work. I think it's always a visual retreat to see your work. I'm trying to wrap my head around a couple of things. One is time becomes very important in your work, right? Especially in your design studios where you have this way of foreseeing what's still not there through a set of visualization of speculating what growth would be and what decay would be in your projects. Maybe I'm overstepping here and trying to understand the projects, but I want to understand in the case of robotic translation and all the projects you showed for robotic translation, how are you seeing that point or moment where you say this is where we stop and let the robot keep going, and this is where the robot kind of stops and we kind of supersede our expectation of what that resolution of work should be. You know what I mean? Like maybe it's there in your explorations, but I want to understand how does that decision making for you happen? Probably doesn't. You kind of let the whole system be there together. If you have any reflections on it.
Yeah, obviously, well, as you can see in the work, time is present, for example, in the project in Los Angeles, right? That performative and time condition, but it's also obviously the road because of the tool. So we allowed certain agency and tolerance to the robot. Obviously, it's based, and to be honest, completely on safety for the students as well. So it is controlled at the end. So there's like a certain gap there that we can actually control, but they can play with that. So we wanted. It's also speculative. I always remember, and actually Peter Tessa, who was my professor and had like an interview in my book, when I was like in his classes, he always said I didn't understand what I was like doing, and then he said, if I already saw what you have in your mind, I don't care. I want to see something new, right? So maybe like these tolerances and these like non-controlled completely options will allow to certain new capacities for the materials or maybe like different results. We cannot predict exactly what's going to happen, but that's also the idea, something unpredicted in a way.
What is amazing about the robot is actually a machine that is actually built up and understood as a precision, efficient, industrial thing. Give a kind of unexpected uncertainty to the process itself. So we really like about the question of using the robot as a translator. It's actually that a machine that is meant to be something else is now in a reposition in terms of all the process. And we actually encourage the student every time they start to do things, like, well, I'm going to follow the protocol. Okay, no, the protocol is just for you to start the thing. For that, it's up to you how many iterations you do about it. How do you understand those? What happens if you change this or that factor, speed? So it is a beautiful process of also like hands-on kind of working processes. So yeah, time is important, but also time of the processes. So I really like the idea of incomplete process.
Just want to have studio. All right. Thank you very much. We have studio, so your professors want to go back.